So welcome to Everyday Mathematics, and today we are finishing up the MIT 2010 Integration B qualifying exam set of problems. We'll be focusing on problems 24 and problem 25. Problem 24 is the indefinite integral of 1 over natural logarithm of x minus 1 over natural logarithm of x close bracket squared. And then problem 25 is the definite integral from x equals to 1 to x equals to 2 of the square root of 1 minus x minus 1 times the square root of 2 minus x. These are very interesting problems. And yeah, please join me in going through these problems. So on to problem number 24, the indefinite integral of 1 over natural logarithm of x minus 1 over natural logarithm of x squared. So one thing I would like to emphasize here is the natural logarithm of x squared is not equal to natural logarithm of x squared close bracket. Rather, this is the same as natural logarithm of x, natural logarithm of x. This is what this part here means. So the quickest thing I would do is I would say let u be equal to the natural logarithm of x, such that du dx is 1 over x, and so du is equals to dx over x. So this is the first step. Important thing is we've substituted for natural logarithm of x with u, and then we'll have to go ahead and substitute for dx over x with du, and that will make things a little bit more tractable. Our integral of 1 over natural logarithm of x minus 1 over natural logarithm of x. I think the best ways to do that, dx can be expressed as follows. Dx. And so let me just delete that x for a minute so that we write it properly, right? And since this now becomes du, and since we said x is equals to natural logarithm of x, then that means that, u rather, so we said u is equal, then e to the power u would be equal to x. So taking this now means that we have, in place of x, we have e to the power u. In place of natural logarithm of x, we have u, e to the power u, over here we have u squared du. So this is equals to the derivative of e to the power u remains e to the power u over u plus e to the power u, the derivative of 1 over du. So what we've done here is we've taken this to be equal to this, and we've left 1 over u as it is, and then negative 1 over u squared is the same as the derivative of 1 over u. So what we've seen here is that this is the same as the integral of the derivative of the product of EU and 1 over U. So that is what we're integrating, right? And so it's becoming really obvious now what needs to happen. So we've gotten our integral as the integral of the derivative of e to the power u, the product of e to the power u and 1 over u, which equals to obviously e to the power u over u plus the integration constant. But we say it since e to the power u is equals to x and u equals to natural logarithm of x. From here, this is the same as x over the natural logarithm of x plus the integration constant. And that is our answer, ladies and gentlemen. Okay. I mean, the other ways to have looked at it, but I think this is the most straightforward way. So let's progress forward to the next problem. So problem 25, which is the definite integral from x equals to 1 to x equals to 2 of the square root of x minus 1 times the square root of 2 minus x. This is certainly very interesting, and personally I would just like to express it as one big square root. Keep things there so that we have 1 to 2 is 2x minus x squared minus 2 plus x. So this is the same as square root of 3x minus x squared minus 2. And yes, it's the same as 3 over 2 minus x squared right. So this became 3 over 4. Yeah, so if we have 3 over 2 minus x squared, that's the same as 9 over 4 minus certainly 3x plus x squared, right? And so 3x minus x squared is the same as 9 over 4 minus 3 over 2 x squared. So let's box this out, right? So we're going to plug this in here. And we say 9 over 4 minus that minus 2 dx, right? So this part here is what we got there. So this is the same as 1 over 2. 9 over 4 minus 2 is going to be a quarter, because 9 over 4 minus 2 means that's 9 over 4, 9 minus 8 over 4, which is a quarter. So that's the square root of a quarter minus 3 over 2 x squared dx. Okay, so that now becomes very easy. We can now substitute with a trigonometrical function and it becomes more tractable. So integral now becomes as we saw previously, it's a quarter minus 3 over 2 minus x squared dx. So we want to kind of simplify this by using a trigonometrical function. The easiest thing I could say is let 3 over 2 minus x be equal to a half cosine theta, so that when we plug this in, it becomes a quarter cos square theta. We can factor out a quarter out, and it becomes easy. So negative dx d theta is equals to negative a half sine theta. So the negatives cancel, and we have dx can be substituted off using a half sine theta d theta, right? So let's continue. So since we say let 3 over 2 minus x be equal to a half cosine of theta, we can look at the limits x and theta. When x equals to 1, 3 over 2 minus 1 is a half. A half divided by a half is 1. A cosine of 1 is 0. When x equals to 2, 3 over 2 minus 2 is negative a half. Negative half over a half is 1. So arc cosine of negative 1 can be looked at as pi. And so our integral from x equals to 1 to x equals to 2 of the square root of a quarter minus 3 over 2 minus x squared is the same as the integral from theta equals to 0 to pi of the square root of a quarter minus a half cos theta squared times a half sin theta d for dx. So this is the same as to pi. Pulling a quarter out is a half, and so we have 1 minus cos square theta, and then obviously this half also can be brought out here, but let's just keep it there for now. And so let's continue. So we saw that our integral now had come to a point where we have 1 minus cos theta. So this part here is obviously sine square theta, square root of that. It means that if we bunch this to a quarter, and this is now square root of sine square theta is sine theta, and then sine theta, and now we get quarter integral of sine square theta. We know that cosine 2 theta is the same as 1 minus 2 sine square theta, which means that sine square theta is the same as 1 minus cosine 2 theta over 2. Right? So let's continue. So since our integral has gotten us to, and we say that sine squared theta is the same as 1 minus cosine 2 theta over 2, which is the same as a eighth 1 minus same as a eighth theta minus a half sine 2 theta 0 to pi. And we know very clearly that obviously this part here tends to 0 for both limits, pi and 0. So as we go forward, our answer is a eighth pi minus 0, which is pi over 8. and that is our answer. So thank you so much for tuning in. I hope you do have fun following along. Until next time, bye bye.